So let's move forward to the main program and invite our resource person for delivering their talk. Before I invite today's resource person, I request Dr. A. Chandrababu sir, coordinator of this FDP, to read out the profile of Dr. Shivaram sir.
Good evening, ladies and gentlemen. It brings me immense joy to share the profile of this session's notable resource person. Dr. Shivaram Rajayagari is a distinguished academician with nearly 25 years of commendable experience in teaching, research, and development. He holds a PhD in computer science and has successfully supervised PhD, MPhil research projects and numerous postgraduates. He has awarded as a best teacher from several reputed institutions. He contributed his services to the reputed journals listed in Web of Science and Scopus as a reviewer and also published several research papers, book chapters, and patents. His expertise lies in the fields of computer networks, cybersecurity, AI, big data, and image processing. He has an international experience in academics by working in different countries like Afghanistan and Saudi Arabia as well as in India. Currently, he serves as a professor of computer science at Shakra University in Saudi Arabia. Thank you all for your attention. It is now my honor to hand over the session to our distinguished resource person to enlighten us with their expertise. Over to you, sir. Dr. Shivaram Rajayagari, please.
Thank you, Dr. Chandrababu garu. And first of all, I would like to thank the management of PVKK Institute of Technology and the principal Ramesh Babu garu and the coordinators Chandrababu and Kiran Kumar garu. And also I'd like to congratulate you to getting such a program from Atal and AICT, and which is very helpful to enrich the knowledge of faculty members, where the students are the main pillars of the next generation of our country. So we teachers should be the evergreen students. Being a teachers, we are always the students. Like in Telugu, you know, Nitya Vidyarthi, Upadhyayudu Nitya Vidyarthi. Okay. Today's theme, that AI integrated next generation semiconductor device, is a very such a theme you selected. You know, while I came to know this AI, about AI in 1990s, when I am doing my graduation in computer science in Tirupati, SV University. Those days, my professors used to say, this AI is utilizing only 5% in the world. Only 5%. Still, there is a big growth. But you can see now also, it has all happened about 90s means it is a 30 years more happened. 32 years more happened. Even though now the AI is utilizing only, maybe according to my knowledge, it may be 10 to 15% only. Still there are much more scope is there to grow and utilize this AI for the betterment of the world. Generally, along with that, semiconductors. So we know that first, the semiconductors are like that. The computer is supposed to say, just we give the code. Whatever you give the code, according to that, the computers will be executed. But nowadays, the computers are capable of learning, thinking, and communicating. All this is because of this AI impact on the semiconductors. Okay, before going to in detail, we'll start with our presentation. So AI powered revolution, the exploring next generation semiconductor devices and their applications. Okay, up to now, generally, very good information, very collective information as given by our principal, Dr. Ramesh Babu Garu, and how the government is encouraging, and only simply he expressed that only 20% of the designing experts are there, and also we need more manufacturing of this semiconductors are required for the universe itself. It's in a worldwide requirement is there. All these things, when you go through, generally, the AI, artificial intelligence, and the first we'll discuss about understanding AI and its role in semiconductor devices, and exploring of advanced semiconductor materials and technologies, AI-driven performance enhancements of semiconductor devices, emerging trends and future applications of AI integrated semiconductors. These points I am going to discuss with you today, and maximum the remaining sessions you are going to get so many AI related algorithms and techniques and semiconductor technologies and all. So that I would like to give the first session as fundamentals about the AI and semiconductor devices. So before going to discuss about this, we need to discuss about the semiconductors and artificial intelligence are deeply interconnected, with advances in each field driving progress in other. Actually, we know everywhere. Just what we what I told previously. Just give the code, and whatever you given the code, that will be executed. But nowadays, the computers can learn, think, and communicate. So, like this, for this pattern, we can take an example of a washing machine or TV. Wherever you go, the semiconductors are playing a vital role. Like that, suppose to take your washing machine, fully automated washing machine. If you take, you see, just you have to keep all your clothes and give some detergent and all, and switch on. According to the situations and according to the timing, it does all the work and it gives you the washed clothes out. So I don't want to go in deep what is doing all of these things. So there you can know that all this was learned. All this was learned to the machine. To the machine. For that, what we need generally, we need much more data. So more data is collected related to that particular action or the particular purpose, and that will be learned to the machine and act accordingly. So this is in general, simply say in artificial intelligence, machine learning. You can think about machine learning. What is machine learning? We are making the machine to learn. So we are giving a sufficient data is very much important. So if you have to give sufficient data to the machine to act accordingly to take the decisions. So I have a clear overview picture is there. While we are going through this session, I will show that when it is required. Okay. Anyhow, this interconnectivity between the semiconductors and the artificial intelligence, we can categorize, break down this relationship between these two. That is, one is the semiconductors as the foundation for AI, AI-driven semiconductor innovation, technologies and innovation. One by one, we are going to know that semiconductors as the foundation for AI. What is the process power? So processing power. Before going to discussing about this, I would like to tell one thing about the supply chain management. For every product, there will be a process of supply chain management, which starts from manufacturing to supplying to the end user. You may take a clothes or mobiles or something else, whatever you manufacture, and reaching to the end user. But this is entirely different scenarios are there, and procedure will be there. So for class are different, and for the supply chain management. Actually, this supply chain management is we can categorize it into 5 categories. When we discuss about these semiconductors, semiconductors are categorized into 5 categories, as said our principal Ramesh Babu Garu. That is designing, manufacturing, assembling, testing, and packing. So these are all the different categories for the supply chain management of semiconductors. But what about this AI related to this? So here AI, where it need a sufficient data in different stages of these categories, which will give time saving and efficient product manufacturing and covering in the supply chain. So from the beginning, you can say, supposed to say for processing power and AI algorithms, especially deep learning models, require significant computational resources. Semiconductors provide the necessary hardware for this computation. Suppose here you can see that the processing in AI, what happens? The previous designs, the previous models, whatever we have, the semiconductors, it takes all the data and it predicts the errors or the mistakes, and which will not be occur in the process of manufacturing. And also it gets inventory optimization also it will done, because when you have the previous history, all the data, the previous data will be computed, and this output will give to reduce, that means the optimizing the cost of manufacturing such things. Okay, the development of specialized AI chips such as GPU AI chips, TPUs, and neuropathic chips has been crucial in enabling efficient AI processing. Generally, in almost all, every sector we are incorporating this AI. So here in semiconductors, we incorporate this processing power will be enhanced. I have a program, that practical program I will show at the end, how it will be utilizing less power for more production. And memory and storage. AI models need large amount of data for training. So first of all, you have to train the machine that with large amount of data. So how much more information you give, that much perfect and efficient product will come out actually. So the advanced semiconductor technologies are used to create high capacity memories and large solutions that can handle these data requirements. And energy efficiency. AI computations can be energy intensive. So advances in semiconductor technology aim to improve the energy efficiency of AI hardware, making it more feasible to deploy AI in wide range of applications. And AI driving semiconductor innovation. So design and optimization. AI techniques are increasingly used in the design and optimization of semiconductor devices. So machine learning algorithms can optimize chip layouts, predict manufacturing issues, and improve yield rates. So AI-driven electronic design automation tools are used to automate and enhance the design process of semiconductors, making it faster and more efficient. Generally, here this AI in design and optimization, giving the previous data of the semiconductors older version, so that we can remove all the issues, manufacturing issues, and that optimizes the errors like that. And in AI-driven semiconductor innovation, manufacturing, AI is used in semiconductor manufacturing for defect detection, predictive maintenance, and process optimization. Machine learning models analyze vast amount of data from manufacturing process to identify patterns and anomalies. And the materials. AI is helping in the discovery of new materials for semiconductors. So, what are the problems or issues arising in the previous semiconductors, and how can we come over by using other type of materials for the manufacturing of semiconductors? So here we can have so many simulating tools to use using the previous data and the characteristics of that material and how it will be useful. Suppose to say sometimes some material will not hold this heat. So in already mentioned that I was doing my Bachelor of Computer Science in 1991, 92, 94 actually. By 91 to 94 there, I use AT missions, XT missions like that, 8086, 80286, 80386 processors are using, and we can't able to use that throughout the day. We have to use that missions, giving some break, and those days to maintenance of the computer labs also a very big problem. Without AC, it is a problem for the systems, because these chips, the semiconductors will get heated and they will be not working, and they are not useful also like that. So after that, no, step by step using the learning the old semiconductors problems, and it is enhancing their capacities using the different materials with their properties. Machine learning models can predict the properties of new materials, speeding up research and development process. This is another process for research and development is going on the different materials which can be used for the semiconductors. And the technologies and innovations. So here the technologies and innovations where we are applying is neuropathic computing, quantum computing, AI like this. You see here a neuropathic chip designed to mimic the human brain, representing a new frontier in semiconductor technology. It's still under development. Somewhat is came, but preparing for the better. These chips aim to provide more efficient processing for AI tasks by using architectures inspired by biological neural networks. Nowadays uh, we are keeping some chips in our body and in health sector. No need to go to the doctor actually. It will gives your BP, your blood sugar, or your temperature, and your stress levels, and everything. How many calories you burnt? All these things will be gathered with this chip, which is inserted in your body, and that will be sent to the doctor's server, and immediately he will, whenever the maximum level reaches any one of your measurement, then automatically doctor will send a message to you. You have what are the precautions you have to take, like this. So like this neuropathy, neuromorphic computing, here the technology is with AI, and quantum computing. Although still in the early stages, quantum computing holds potential for solving complex AI problems much faster than classical computers. Quantum semiconductors are a critical area of research in this domain. And AI, the trend towards edge computing involves running AI algorithms locally on devices, like example smartphones, IoT devices, rather than in the cloud. So if the AI algorithms all has to work in your system, suppose in your smartphone or IoT devices, it requires this requires semiconductors that are not only powerful but also compact and energetic and efficient, because we said it needs more memory also to have the data for the input for these algorithms to learn the computer to take right decisions. Discuss about the AI with semiconductor. I would like to give a short note on that. AI, actually the artificial intelligence is a vast subject. In the subset we have machine learning, and then neural networks. The subset of this is deep learning and generative AI, like that we have. And for all this, we need to attach with the this is data analytics. Data analytics is also one of the part we have to add with this. With the data, the sufficient data, when you have the sufficient data, only you can get the AI should be effective and time saving. And come back to this understanding AI and its role in semiconductor devices. Generally, we discuss about this introduction to AI in semiconductor technology. There we cover the brief overview of artificial intelligence and machine learning, and the importance of AI in revolutionizing semiconductor design and applications. Examples of AI integration in the semiconductor industry. And second point is the semiconductor integration with AI. Role of AI in process optimization, yield improvement, and defect detection. And some case studies: AI impact on chip design, NVIDIA, Intel Advanced, like this. And coming to the second point, explanation of advanced semiconductor materials and technologies. Here we'll go through the introduction to advanced materials, where overview of cutting edge materials like silicon carbide, gallium nitride, two-dimensional materials, like, and innovative applications of AI driven semiconductor materials. enhancing energy efficiency in power electronics, enabling high-speed communication in 5G and 6G technologies, and practical demonstration in Python, some Python libraries using NumPy and Pandas. We use semiconductor material properties and visualization of silicon carbide versus gallium nitride, efficiency in power devices. And the third is AI-driven performance enhancement of semiconductor devices. AI algorithms in semiconductor design and optimization, where regression model for predictive performance optimization, neural network for fault detection and mitigation. So everywhere, finally, what we generally go through is mainly the machine learning as well as deep learning will come occur in this semiconductors. Applications in emerging field, Internet of Things, AI enhanced microcontroller for smart devices. Suppose if you go through this AI, semiconductors, IoTs and all, which will make the efficient performance in the industry and the technology, sometimes there is no need of more human interaction in this system. Autonomous systems, AI integrated chips for real-time decision making, and we'll go through some practical demonstration Python. So here, before going to detailed about this, I'd like to view some the impact of AI on semiconductor manufacturing. First of all, in the manufacturing, they using this AI, quality, speed, cost, and outcomes will be very high. So the quality, the semiconductor quality is crucial and can improve further by utilizing AI services. And the speed, leveraging AI-driven optimization can increase semiconductor manufacturing throughput. So here, the optimization can the increasing semiconductor manufacturing means when we have the issues in the manufacturing, already we know the issues and problems in the manufacturing of the semiconductors. By this AI, we can predict and we can avoid that issues and make it more productive so that we can have increase the semiconductor manufacturing. And the cost also, AI solution increases the operational cost. Thus, companies have to be selective in utilization solutions. And outcomes, eventually AI solutions driven positive outcomes, thus helping companies develop high-tech products. So this is the impact of AI on semiconductor manufacturing. So according to the demand of the market, we can assess the requirement so that requirement planning can be done with the AI, and also logistic and shipment also can be done with the previous experiences like data. So we can make the machine to the algorithms that the demand, how can we reach the demand of the market. And okay, and the fourth point we are going to discuss like emerging trends and future applications of AI integrated semiconductors. The future trends in AI integrated semiconductor technologies: AI acceleration, edge computing, AI and quantum computing for semiconductor innovations, and potential applications across industries: telecommunications, AI chips for signal processing, and renewable energy systems, AI optimized solar inverters and power grids, and healthcare, AI-driven semiconductor solutions in wearable health monitoring devices, and some practical demonstration will be shown. Okay, and something about before going to detailed discussion, the future of the semiconductors, advancements and innovations to watch out for. Forefront. The semiconductor industry has been at the forefront of technological innovation for decades, driving computing progress. Several innovative solutions like quantum computing, silicon photonics, and next-gen process technology will shape the new applications. Applications. Several new consumer and enterprise applications will get created on top of the never-seen semiconductor technologies. Both technical and business progress will co-occur to keep the semiconductor industry ahead. Okay, generally today's topic what we are discussing is categorized into part 1, 2, 3, 4 like. So again back to our understanding AI and its role in semiconductor devices. So introduction to AI in semiconductor technology. AI and ML are transforming semiconductor technology by automating complex processes, optimizing design, and enhancing performance at unprecedented scales. And brief overview of artificial intelligence and machine learning when you go through. Actually, we know this machine learning is the subset of this artificial intelligence subdomain. AI focuses on building intelligent systems, while machine learning enables these systems to learn and improve from data without being explicitly programmed. Importance of AI in realizing semiconductor design and applications. AI accelerates innovation in semiconductor manufacturing by improving accuracy, reducing production cost, and enabling the creation of smaller, more efficient chips. So, from the beginning, overall, we are discussing the same points that where here just we are point-wise discussing examples of AI integration in the semiconductor industry. AI-powered systems are widely used in chip design. Example, layout automation, manufacturing defect detection, and predictive maintenance, setting new standards for the industry. Semiconductor integration with AI. Role of AI in process optimization, yields improvement and defect detection. AI enhance semiconductor manufacturing by optimizing production workflows, improving chip yield rates, and identifying defects in real time, leading to higher efficiency and reduced cost. So, when the AI is integrated with the semiconductor, the growth of the semiconductor industry is now growing very fast. You know, China, Taiwan, and even now America is also showing more interest and investing more money on that to develop this semiconductors, where AI made it encouraging to do all these things, where it gives the production cost will be reduced, and it gives more production. And case studies, when you go through that, AI's impact on chip design, NVIDIA, Intel advancements. Companies like NVIDIA and Intel levers AI to accelerate chip design, enabling faster time to market, enhanced performance, and innovative architecture that support advanced computational demands. First, we have the IBM and Intel chips. Now, AMD is also there. Chips which has got a very good market 1 decade before, but nowadays again Intel and Nvidia are the more existing semiconductors chips are there, and exploration of advanced semiconductor materials and technologies. So here the introduction to advanced materials, overview of cutting edge materials. They are silicon carbide, gallium nitride, and two-dimensional materials like graphene and MOS2. Here the silicon carbide, known for the high thermal conductivity and efficiency, and silicon carbide is realization power electronics by enabling high voltage applications with reduced energy loss. So this is the advantage of this silicon carbide. And gallium nitride is a combination of two elements, that is gallium and nitride. GaN offers faster switching speeds and greater efficiency, energy efficiency, making it ideal for application like 5G technologies and electronic vehicles. Nowadays, automated cars are coming, driverless cars also. There they are using this gallium nitride used semiconductors. And the two-dimensional materials, these materials provide exceptional electrical, thermal, and mechanical properties, paving the way for next generation semiconductor devices, which unprecedented flexibility and miniaturization. So you can make it very small also, very tiny, these things. Yeah. For this you can see early stages. So you use this germanium as a for the manufacturing of semiconductors, and now we are using that silicon for the manufacturing of this semiconductors. But the next generation where they are going to use, now already they are under process, the silicon carbide and gallium nitride, where already we discussed about the silicon carbide, where is the low switching loss and high speed switching, high voltage resistance, and high thermal capacity is there. But this gallium nitride, the advantages of gallium nitride over silicon and other semiconductor materials is its increase in efficiency and size, reduced size, and also the production cost is also reduced cost. So fast switching speeds, lower on resistance, and lower weight and lower cost. So this is the next generation materials for the semiconductors, and innovative applications of AI-driven semiconductor materials. Enhancing energy efficiency in power electronics, AI-driven materials like SAC and GaN improve energy conversion and reduce power loss, making power electronics more efficient for applications such as electronic vehicles and renewable energy systems. Already I told about my experience in when I am working on 8086 and 8085 and 80286 like XT80 like such systems. The chips were becoming heat actually. They become with the processing going on processing some heavy processes, it becomes stuck, and the chips will become very heated very much. So to avoid that, nowadays these materials are used to making power electronics more efficient for applications, and also for electronic vehicles and renewable energy systems where you use more heat generation are there, but automatically the automated systems has to work means it has to sustain with the power, heat resistance should be there. So in such cases, these advanced materials are very useful, and enable high speed communication in 5G and 6G technology. So the AI integration of the integration of AI with advanced materials facilitate faster data transmission and lower latency, enabling seamless communication in network generation, wireless networks and all. So these advanced materials help us in the 5G and 6G communications also by facilitating faster data transmission. And there are some practical these things. I would like to ask the coordinators, please share this code to the participants and they will practice so that they can get the results. Here the practical practice is Python program using NumPy, Pandas and Matplotlib to analyze and visualize the efficiency of these two materials in power device across different voltages. When you supply different voltages, what are their consumption and how they will work. This is the code for that. You can see we are giving some voltage levels 100, 200, 300 and 400, 500 like that, and also the efficiency for the silicon carbide 90, 92, 93, 94, 95, the efficiency percentage, and also gallium nitride is like that. So when we now will create a data frame by visualization manipulation like this, and when you run this program, you will get this efficiency measurements. You can see the voltage 100 when you give the silicon carbide will have efficiency of 90%, whereas the GaN efficiency will be 85% only utilizes. So you can see the efficiency between the silicon carbide and gallium nitride. It will this utilizes very less. So you can see this graph also where the efficiency of gallium utilizing this percentage of voltage is very low compared with the silicon carbide. So please, I request the coordinators, please supply this material to our participants where they can see the difference. And AI-driven performance enhancement of semiconductor devices, AI algorithms in semiconductor design and optimization. Actually, the algorithm regression techniques are utilized for predictive performance optimization, allowing semiconductor devices to achieve better operational efficiency by analyzing historical data trends. So there are we have to use the regression models for optimizing the performance so that we can predict to improve the operational efficiency and analyzing the historical data. That means whatever the previous semiconductors in the design, what the effectiveness can be done, and by using the new using the models, these algorithms will make you optimizing the semiconductor better operational efficiency. And neural networks will be used. Deep learning neural networks are deployed to detect faults in semiconductor manufacturing and operational processes, enabling proactive mitigation and reducing system downtime. So the regressive model is used to better operational efficiency, and these neural networks are used for operational process, enabling proactive mitigations and reducing the system downtime. So where it can detect the faults in semiconductor manufacturing and applications in emerging fields. So Internet of Things, AI enhanced microcontroller are transforming smart devices by enabling efficient data processing and decision making within IoT ecosystem. Autonomous systems. AI integrated semiconductor chips facilitate real-time decision making for autonomous vehicles, robotics, and drones, ensuring precision and reliability in dynamic environments. So almost all we can see these autonomous systems generally nowadays vehicles are there, automatic parking they are doing. So how can they are doing the automatic parking in a given place? Usually it has to take the real-time decision there itself. Accordingly, the vehicle has to park. So the AI is nowadays ensuring that precision and reliability in the dynamic environment. And for this, here is a program. One is to predict the thermal efficiency of semiconductor devices based on the sample data. The program also visualizes the prediction using a scatter plot and regression line. So here giving some sample data to find the thermal efficiency of the semiconductor device. So here we are given some data like operating temperature is 25, 50, 75, 100 like this, and the input power and some like that. We are giving different sample data for the predicting of thermal efficiency of the semiconductor devices. So with this code we can visualize like this. So mean square error is 0 and R square is 1. You can see thermal efficiency prediction, the actual data, and this is giving the predicted regression line actually. So operating temperature when it is increasing, and thermal efficiency how it is propagating. You can see from 150 it is 65. And it is coming, temperature is going down actually here. And the emerging trends and future applications of AI integrated semiconductors. Future trends in AI integrated semiconductor technology. AI accelerators in edge computing. AI accelerators such as tensor processing units and GPUs are transforming edge computing by enabling faster data processing and decision making closer to the source, such as in IoT devices and autonomous systems. These trends reduce latency, enhance real-time performance, and support applications like smart cities and healthcare monitoring. So in edge computing, for example, suppose to say in GPU, graphics processing unit or tensor processing unit, or even if you see in our Google map, sometimes we find whenever you are on the way, you can find the traffic is more or medium or less or general, like that. You can see that traffic time to time. So how this will be, you can know. That means everybody, whoever using this Google Map in their vehicles, in their devices, when the vehicle is moving, the acceleration will be calculated. If it is stopped sometime on the road, that means it is a heavy traffic. It is accelerating, moving slowly, means it is traffic is somewhat medium. If the car is moving very speed, means okay, there is no traffic in that. So that is the data is going to the server, and there this data is analyzing that. According to that, again it is transforming the information to the Google Map, that the forthcoming road, how the coming road, how it will be the traffic, like that. So like in edge computing, and also like we can see there is healthcare monitoring also. And just before I told that you can have smart watches also we have in our wrist, where it will give all the data about your how much distance you traveled, and what is your stress, and what is about your blood pressure. All these things, it is time to time it is recording, and then it indicates us the precautions to maintain our health. And the another point is another feature is AI and quantum computing for semiconductor innovations. The integration of AI with quantum computing is opening new frontiers in semiconductor technologies by solving complex design and optimization problems that are beyond the reach of classical computing. This innovation has the potential to revolution material discovery, enhance computational efficiency, and drive breakthroughs in semiconductor device performances. So, and potential application across industries. So, where all these applications are there, no, in telecommunications, renewable energy, health systems, wherever, in almost all telecommunications, AI chips for signal processing, AI-driven semiconductor chips enable real-time signal processing and optimization in telecommunications, ensuring fast and more reliable communication in 5G and upcoming 6G networks. And renewable energy systems, AI optimized solar inverters and power grids, AI generated semiconductor solutions enhancing the efficiency and reliability of solar inverters and power grids, optimizing energy distribution and reducing wastage in renewable energy systems. And healthcare systems, AI-driven semiconductor solutions in wearable health monitoring devices. Semiconductors powered by AI enable advanced wearable health monitoring devices, offering precise real-time data analysis for early detection and better prevention of the diseases and all. And for this also, a real-time trend analysis for semiconductor market trends. It uses a publicly available data set to plot current trends and an AI model to predict future demands. So for this, we have one more practical program which can be given semiconductor market trends and predictions. At the beginning, where our Dr. Ramesh Babu, our principal, has given the tremendous requirement of the semiconductors for the industry. So how it is growing. In general, semiconductor demand in billions of units actually, and in 2017, 20, 22, 25, like that, when you go, it is increasing the requirement. So this is a good advice to our all students community through our faculties or through our teaching community. Make the awareness of this demand, semiconductor demand, to the students, and make them to empower and strengthen their skills for the designing and manufacturing of these semiconductors. This is all about today's topic.
So thank you, sir, for your valuable information and time. You have given a
Thank you.
wonderful session, a very informative session, a scintillating session. You have covered the entire gamut of AI and its technicalities related to this. So thank you very much once again, Dr. Shivaram sir, for giving such a wonderful talk.
It's my pleasure, and I am very thankful to you by giving this opportunity. It's welcome for your and also very great initiation you have taken with this theme. Once again, thank you for you.
Okay, sir. You are welcome, sir.